Yes, Renuka, this will be shared with you by email. Okay, let's start. So, yeah.
Yeah.
So, welcome everyone. We are doing this recommendation system deep dive today. Uh, this is the third project that we are doing. We have done object detection and customer lifetime value before this. So, let's start. Uh, yeah, you can go to slide 4.
Exactly for. Okay.
So, if you guys don't know me, so I'm Ashif, and I've been working as a data scientist for uh, more than 2 years now. And yeah, I, Mithul and Sushant host this podcast and masterclass is called Data Production. And feel free to connect with us on LinkedIn. Mithul?
Hey everyone, so about me, I work for the Catalan as a data scientist. And yeah, welcome everyone. I can connect with me on LinkedIn.
Sorry.
You can go ahead, Sushant.
Okay, cool. Yeah. Hey, hi everyone. I am Shashank. I am data scientist currently at Geo. I am working mostly towards recommendation part. So right now, this masterclass will be regarding the recommendation. So we will start with the problem statement, what we are going to solve in this masterclass. Okay.
So, first of all,
quick-
so how many of you
So-
know what recommendation system?
So before everyone answers, quick question for everyone. Do you guys prefer in English or Hindi? And then we forgot to run the poll. What do you guys prefer? You can put it in the chat. Okay, one English. Anyone else? English? Okay. Okay,
English
I guess English it is.
Yeah.
So, anyone who knows what is a recommendation system and where they are used, you can raise your hand, unmute, or type it in the chat, anything. So Ravite just says Amazon and Netflix. Yes. So what exactly is a recommendation system? Anupama says e-commerce. Yes. Personalization. Suggestions. It recommends us new things based upon our previous choices. Correct. Group says showing products as per our need. Recommends movies, products for individual users according to your previous searches. So, Sushant, so are these answers correct?
Like according to previous searches, I recommend a movie product for individual users. Yes. So let's see what it is from the scratch. Okay. So we are going to take a problem statement, which is movie recommendation system. I think most of you have heard about it. So if you have seen the Netflix, you have if you watch some movie and you are going to get some uh, recommendation based on that. So how that works, we are going to learn about it. Not like Netflix users have quite deep model to which they trained on their data set, but we are not going to very deep in it. But we are going to know about the basic of it, how it works, and what are types of recommendation, and how we are going to, what general recommendation we see in our in day to day our life. Okay. So yes. So what we are doing. So what is your next movie? If you are going to, if you are watching Netflix, you are watching some movie. So based on your previous history, what next movie you are going to see in this in the recommendation is the basically which we are providing. By providing personalized movie recommendation, business can enhance user engagement. Let's say if you watched some movie like Mission Impossible, what next movie you should watch, that we will find how this similarity metrics and how this recommendation system help us. So if we talk about in general recommendation system is an algorithmic tool that uses predictive model to suggest us recommendation system is a system designed to suggest items user based on their previous preferences and behaviors. Okay.
So I have a question for the people who have joined. So can anyone tell me what is the difference between a recommendation system for a movie versus food? Anything special? What do you guys think? So like, should both of these recommendation system be the same, or is there any like fundamental difference? So think about Swiggy versus Netflix.
And guys, you can unmute yourself. Let's make this an interactive session. The more interactive it is, the better it is for everyone. Everyone's going to learn. Let's take advantage of it.
So we are getting a lot of answers, but none of these are like very fundamental. So Amar is saying video versus image. So yeah, that is okay. Okay. Any like even more fundamental difference? Veg versus non-veg? No, but movies also have veg versus non-veg, right? Food depends on the restaurant it is prepared, but movie is not. Okay. So I think one of the most fundamental differences is that so one of the most fundamental differences is that if you have already ordered some food and you liked it, you would like to try that again. But that is not the case with the movies, right? You won't want to watch the same movie again, right? So that is like very fundamental. So yeah. So Shanti, please go ahead.
Yeah. So we were talking about what are recommendations. There are basically three types of recommendation system. One is collaborative, second is content, and third is hybrid. So we mostly going to talk about collaborating filtering here. Collaborating filtering is mostly when where data set is created with the user's item interactions. So let's say when we have data of users and we have data of items, let's say, and there's some interaction between them. Like you watch some movie, there's an interaction. You buy some product, there's an interaction. So we will use that data to create a recommendation that is called collaborative filtering. There's another which is called content based, basically content based, like if you say there's a movie, let's say Mission Impossible. Mission Impossible has Tom Cruise. Another movie which have Tom Cruise is maybe they are similar. So it is called a content-based kind of recommendation system. Which third one is hybrid, which is the mixture of collaborative and content-based recommendation system. Basically, that is mostly used in this current most of the use cases right now. And like if you think about Netflix, if you say about other like Amazon or all these channels, they use mostly hybrid recommendation system right now. So so we will going to talk about mostly collaborative filtering. So what is collaborative filtering? Collaborative filtering is user item interaction to generate recommendation. Let's say this guy liked this movie Pirates of Caribbean, John Wick, and this is Mission Impossible, and he also liked this Matrix. So we will find this this user interaction.
Prashant, can you do a slideshow? Can you start the slideshow on the top right?
Oh, yeah.
Yeah.
Okay, cool. So, so let's say this user liked all these four movies, and this user only liked this movies. We will find we will calculate the similarity matrix between them, and we will try to find like how this can we recommend this movie to this user if he or she is not watched it yet. So we will try to do it using that. And in collaborative filtering, there are mostly two types of filtering. There's a recommendation system. One is item based, and second one is uh, user based. So basically, when we do item based filtering, that let's say
Let's ask the people first. So what do you think is item similarity? You can put it in the chat or speak out. So in the recommendation space, there are two kinds of entities. One is a user and one is an item, right? So what do you think is an item similarity uh, based recommendation? So Dishan is saying same genre, uh, sort of,
no,
right? No?
no,
Okay.
Basically, same ratings, I mean, for the items, right, by the users,
yes,
right?
Hmm.
yeah.
That would be item similarity.
Yeah. So basically, like if different users like the same thing, then is that it, Sujan?
So basically, when we talk about item similarity, let's talk about a simple example. Let's say there's a certain set of people who buy tomatoes. Let's say, giving a retail example, and like the most broad product is tomato and onion together. So what will you buy if there's another guy who's buying tomato with let's say ladyfinger. So these two, we will find that this tomato is common, and these two items are being brought together. What is probability that if I show someone who's buying tomato and like onion, and next time he come to our platform, we want to increase the like number of items in his carts. So let's show him like ladyfinger also. So we will try to find it. We will show you by example like how it works, so then you will understand basically more. So like when you see something, like if you go to basically the basic example will be like if you go to Swiggy checkout page, you will see a lots of item. After adding to cart, you will see the recommendation. These are item based recommendation. Tomatoes are similar, the product is similar to another product, not the users. So when you open like home page, you see already there are lots of already recommendations shown to you. So that is basically user based recommendation, because you are similar to another user. But in case of in item based, it is only items are being compared. Is it similar or not? Understood?
Any doubts, anyone? Any questions? Okay, let's go ahead.
Okay. um okay, cool. uh,
Sorry
so
for interruption.
yeah, please.
Like we do item recommendation and user recommendation
Hmm.
based on the data for
Hmm.
particular user. If you do item recommendation, he will get that bucket of recommendations same or different.
Okay. Let me give you this example. Okay, so we are in it will come in next slide, but let me give you here to understand it better. So this is a data. Let's say this user A has seen rated this movie 5, rated this movie 3, and movie 2 3, and rated this movie 3 4 and 0. This is what the rating is. Okay, so 0 is basically he has not seen this movie. He or she has not seen this movie. Okay. So when we have to find this recommendation from movie one and let's say for user, so what we will get here, we will get how similar this user A and user B are. Okay, is it clear
Yeah.
till now? Okay, so we will calculate the distance between similarity between user A and user B. Okay, and if we calculate the distance between similarity between item A and item B, here in case of our case it is movie and movie 1 and movie 2. When we calculate the like similarity between these two movies, these two items, it will be item similarity. So what we will do, like, is this movie 1 is similar to movie 2? If it is similar, if it is highly similar, we can show it to the end user. But in case of user, what we will do, if user A and user B are similar, we will show all the items which user A has not already shown to user and which user B and user A and B have not seen, and then we will show, like, let's take the example only. Like here, user A given 5, 3, 4, 0, and user B has not seen movie 1, and he has seen the 4, and let's say these are the, and they have similarity of 5.538. Okay, so what we can do, let's say it is a highly similar, we can show the user B the movie 1 and movie 4, movie 3, sorry, and in case of user B, we will show user movie 4 to the user A. Is it clear?
Yeah. So
Like,
basically, yeah, please. Yeah, go ahead.
like user A and user B similarity is like for suppose 0.538.
Yeah.
Like you are saying that whatever movies user A not seen but seen by user B will recommend to the user A.
Yes.
But what if user B is rated very low? Is it recommended to user A or not?
It in case of cosine similarity, it will not. But in case of if this like, if we are taking this numbers as like 5, 3, 4, this instead of like just a flag, if we are showing it just flags, then it will recommend. But if it isn't, we are giving right now is rating, like 5 is the highest rating, then rating will also impact it.
Yeah, it's like a weighted similarity.
Yes, kind of.
Thank you.
So anything above 50% is considered as a high similarity between two
totally
different
dependent
users.
upon the data. It's totally dependent upon the data.
I mean, in this case, the user similarity between user A and user B is 0.35, which is more than 50%, which means
Yes.
that whatever movies A has seen, that can be shown recommended to B and
Yes.
vice versa. Is that the
Yes.
case, right?
Yes.
Okay. So at least in this case, if it is more than 50%, then one person movie's choice can be recommended to other person.
Yeah.
So we have two questions. So Dishan asks, between user A and B, only one movie is similar. So it is not about similarity within the movies, right? So within A and B, so I think only movie 2 is common. So that is, movie 2 is a movie that both have watched and rated. That is the case. So we are not saying that any movie is similar to any other movie.
So in
We are
this
just-
case, we are calculating user similarity. So we are calculating user A and user B similarity, not movie similarity. So we can give user A can watch all the movies which user B has watched and have high rating.
Yeah.
Is it clear?
Another question: what will be the max value of similarity?
1.
Will be 1, right?
Yeah.
I have a question. So user A, user B user similarity, based on that, we can recommend movies to other users.
Yes.
What do we achieve by finding the item similarity in this case? Can you just like
Okay, so basically item similarity in our case is that more useful. Let's say these two are movies. There are two movies, movie 1 and movie 2. We will find the similarity. If it is highly, if it is, let's say the similarity score is above the threshold, so we can directly we know that user 1 has already watched this movie, but he hasn't watched movie 2, so we can show that movie 2 to the user. Is it clear? Like if
Okay.
A and B are highly similar, A and B are highly similar, like movie 1 and movie 2 are highly similar, and user A watched movie 1, so we can recommend movie 2 to the same user.
But if we go by that case, user A has already watched movie 2, right? If I understand
Yeah,
it
I'm
correctly.
giving just I'm just giving an example. Let's say user B. Let's talk about user B. Okay, here user B has not watched, but movie A and movie 2, movie 1 and movie 2 are similar, so we can show user B to this.
Okay.
Yeah.
Yeah, thank you. I get it. Yeah. So since the similarity between movie 1 and movie 2 are high, and also the fact that user B has watched movie 2, we can recommend, or he can be recommended to watch movie 1.
Yes.
Yeah, thank you. Sorry for that.
Another question, how did you consider the rating for movie B for item similarity? Movie 2, I think she means movie 2. How did you consider the rating for movie 2 for item similarity?
No, is it like the question is not clear?
Yeah, so Anupama, these are the ratings given by the users to all the movies that they have watched. So in our whole database we have 4 movies and 3 users. So the numbers that you see right here in pink, so they are the ratings given by the users to the movies. So that is how you get the ratings. Was that the actual question, Anupama, or is there something else?
Yeah, basically, I was little confused because we were actually recommending a movie for user A, right? So there, over there, we are calculating the item similarity with the ratings of the movies that were watched by user A.
No. I think there's some confusion. Like in case of item similarity, we are not recommending it to any user. We are finding that these two movies are similar. Those who has watched movie 1 can also see movie 2. Okay, so if let's say in case of user A, he has already watched 5, he's already watched movie A and B both. Okay, so there's no need to share the same recommendation to the user A. But in case of user B, has watched movie 2 but not A, not movie 1. Okay, so we can recommend this to user B. Similarly, in case of user C, user C has watched movie 1 but not uh, 2. So we can recommend this user movie 2 to user C. Is it clear now?
Yes, it's clear now. Yeah,
Okay.
thank you.
Yes.
So I think there's always confusion between, even myself, I get always confused with the item similarities and user, right? So, when it's item, just don't think about users, right? There's no user word in item. So always think about items. When it comes to user, then start thinking about users, right? So just take users out of the picture for item. That's it. So then there won't be any confusion.
And in both cases, we are only recommending items. We are never recommending users. Okay. So in both cases, let's say, so when we are finding the cosine similarity between user A and user B, we are finding the similar users, and then watch what user A, what these user has not watched. So we are only recommending items, not users.
So except on a dating app, when users become items, right?
Okay. I have
Okay,
not much idea about it.
Yeah, so end of the day, it's all about recommending products to people. That's it, right? So
Yes.
the aim of those two concepts, user item is just about recommending the product to the users.
Yes, but like at what place you are using it is important. Let's say if here we have written, so mostly the item similarity is used on the checkout page and product pages. Let's say you brought some keyboard, so the keyboard is quite similar to the mouse. So maybe you are going to get recommendation of this. You can buy this combo. You have seen it on Amazon.
Yeah. All right, let's move ahead.
So similarly, this user similarity is quite similar to user. So we have seen all this and here in this example. So just when we have to calculate this similarity, we calculate the cosine similarity between user A and user B. In item similarity, we calculate similarity between item A and item B. Okay. So and where you find this user similarity. So mostly when you go to, let's say, take the example of Swiggy only. When you open the app on Swiggy, you will see a lot of recommendation, even without based on your previous purchases. Like there they calculate all your history of the lot, like taken the history of what you have purchased, and they will try to find they will try to match you with another user. Okay, and that user, and they find the similarity between that user, and then they will show you the recommendations according to that this set of users you are similar to.
So basically, do you have any idea like what happens when a new user comes to Swiggy? So he does not have any history of food items. So how does that happen then?
uh, Anyone?
Like popular
Yeah.
movie will recommend.
Yeah. So there's a name for that problem in this in recommendation system, that is cold start problem. Sorry.
Yeah. So Dishan is saying location based. Yeah, I think location must be one of the parameters.
It can be, yeah, it depends what you are taking.
Yeah, I think
So
if you're in Hyderabad, I think there'll always be biryani recommended to you, right? Is that it?
yes.
Age
Yeah, we
group.
consider all these things: age, location, top items which are being sold in this at your location,
Like
top
user
item. Yeah,
based
sorry.
on user segments, cluster
Yes.
segmentation.
Yes, that can also be said at that. So if you have lesser information, then location is the biggest cluster you have. Yes.
So I think Sushant has worked with Dunzo before, so he's an expert on this.
So yeah, on YouTube, if we don't log in, we are recommending. Yes. Yeah. Yes. Yeah. So yeah, so cold start problem starts when a user come to a platform and he don't have a lot of history. Like as we all know, like for recommending anything to you, we need your previous behaviors on the platform. So if you don't have a lot of previous behavior, we face a problem which is called cold start problem. So how we will deal with it? So as most of you told us, with location, age, like sometimes we also consider the phone from which you are coming on our platform. So lots of data which can be considered, uh, which are available via when you log in to the platform. So let's say all the available data which is related to the users, let's say.
So iPhone and Android users will get
Have
different recommendations.
Yeah, possibly. I don't know. And yeah, location is also important. And so so in our case, like in case of movie, we also like segregate it on age basis and language basis and uh, genre basis. All these things can be considered, but for our case example, we have taken genre only. So let's uh, move towards the code part, or
Yeah,
or
sure.
do you guys have any questions till now?
So if anyone doesn't have a question, so if you guys want to code with us, you can open your Colab and pick the data set. We'll put it in the chat. data set, you can go download it, and you can start coding with us if you want to, do a hands-on.
So Dishan is saying in some sites they ask basic things like language, favorite actor, genre, and stuff. Yeah. So what all does Netflix ask? I think it asks, I think, your favorite shows, right? Like the ones you have already watched, something like that.
The
No,
first time you're signing up,
Yeah.
no, they don't ask anything.
No, no,
I don't think they ask anything.
They
And
recommend based on the location.
Yes, that's the cold start problem. You like companies like Netflix just don't use location only. They use a lot of thing. They clusters on the basis of users and all. Locations. Yeah, with location they get a lot of data only.
Is it possible that if the person who signs up newly based on his age, he may recommend like a popular web series where most of the people of his age watch that. So
Yes,
is that
yes, it
also a
is.
criteria?
Yes, with
Okay.
all this with all this aggregation, let's say for this age group, this location, this are the top 5 series which user can watch, let's say. We are simplifying it. There's a lot more complex things happen behind this, like the big companies do. So, but yeah, in the basic, if you have to understand the basics, these are the basic things happen. Yeah, Spotify ask for favorite singers. Yeah, and also I think language also they ask.
one of the popular platform that probably everyone knows it, Medium, right? So when you sign up on Medium for the very first time, it will ask you, whatever the kind of things you're interested in, right? And based on that, they recommend.
Yeah, and like YouTube also do like so when you watch some video, they take care of like is it you watching it fully or you are watching it on only 10% and 20% and getting drop off. So all this data they store and they use it while creating the recommendation.
Okay, I think it's a good time to move on. Yeah, to move on to coding part.
So the data set which we have used is this movie lens data set, which is 100K data movies ratings are present here, and there are 943 users and 1682 movies. So one thing which I want to add here is like this why item similarity. What are the advantage of item similarity? So the major advantage of item similarity is it is uh, quite scalable. So because let's say on the platform you may have millions of users, but the number of content it will be limited. So you can easily find like the calculations behind this all metrics and the cosine similarity and all. It will be much more less complex compared to if you have a millions of data users data. Is it?
Yes.
So
we'll put all these links in the chat if you want to do it right now with us. Mithul, can you put these links?
okay.
Susan, you can zoom your screen.
Shashank, if you want to give a quick overview of your repo, where people can find the stuff, I'll put the link in the chat. You can just give a quick overview.
Sorry, I'm not able to understand.
You can just show where people can find things in your repo,
Okay, yeah, cool.
your GitHub repo.
So this is one basic file which we have used. This is the link of repo. I think this is public, and kind of we will also add this collab to this this Git Right now it is not there, but we will add it there. So, and so what we are going to do here, we created this repo, and yes, this repo where there's a main file where we are doing all this metrics calculation and all, and we have written some function where there are a lot of things which we will explain, and also after that we deployed it in eternal Streamlit. I think you guys know Streamlit. Streamlit, we will test how this is working. Okay, so let's start with the basically implementing, importing all these libraries firstly. So, so we all know that like this is pandas, this is numpy, and this is scikit-learn, and this is scipy. Okay, so we are importing this necessary libraries to this, and this is for mounting the drive to the. So we have pasted the data on our on Google Drive. So we are doing it just to do it here, and then we will load this data. We are reading the CSV file, which is separated by and this is headers, and we are adding the names. So we will see this, like this is like if you want to see what is user data, this is user data. U data is the user data, where user ID, item ID, and their rating and their timestamp. We are not using the timestamp right now. So these are the things. Okay, and when we go to the user item and this data set, it is like there's an ID for item ID. This is movie title, release date, all these things, but we are mostly using this item ID and like here. Okay, and genre from this, I think genre is also there. So, yeah, we have, yes, this genre part is also there, which we are using. Yeah, so so what we are doing here, we are creating a simple एक function which is where we are finding that user which take the item ID as an input, and k is equal to 10. K is basically number of recommendation which we want to show to the end user. Okay, and minimum rating is 5. Basically, if a movie don't have at least 5 ratings, we will drop it. Like if a movie is not rated by 5 users, we will not take in this similarity matrix. Okay, is it clear?
Yeah.
So the just to be clear, the first thing we did is we read the data, and we have printed all the features which we want
Yeah.
in this movie recommendation system.
Yes.
And there's not much pre-processing, right? That is all, right?
No,
Just,
there's not
there's no
much
need of any more pre-processing.
So if you're trying to do a much more complex part, then we can use like a lot of pre-processing. Like let's say you want to do is it like so there's a few movies which are very old, so you want to normalize their rating, so you can try to doing some pre-processing, that giving normalizing the weights. But right now we are not doing it here. We are doing some very basic stuff, like we are trying to find this very basic similarities. Okay, so so if they so what we are doing is so we are finding this user item matrix, which we will make it here. So let's go to this after this. Okay, so we are creating a user
There's a
item matrix.
question. There's a question. There's a question. Genre is one not encoded. Yes, right.
Yes,
But we are not using it.
genre we are using it for cold start.
Only cold start. Okay.
Yeah. So it is we are calculating, pivoting the data to get user item matrix. So how we are pivoting it? Indexing or item ID, and columns are user ID, and values are rating. So I think everyone knows pivot. Yes or no? Okay, I think it's yes then.
No.
You can maybe just take that code and just run it myself and then just show it with how the data was before and how it transformed.
Yeah, yeah.
Okay, so we have
That's the
seen
easiest thing to do.
we have seen the U data. Okay, we have already seen the U data. U data looks like this. Okay, and when we do the pivoting, what will happen? See, so this index call like there is an index, they're double indexing basically, where the top index is this user ID, and this which we have seen, this column name is user ID and index name is item ID. So we created this whole matrix where columns are user ID and rows are item IDs. Okay.
So this is
And
just like the metrics that we saw in the slides, the
yes,
movie and users, right? So we are just converting our original data into this form.
So just to give you a brief, overview of pivot, right? So what it does is basically, you have rows, so you pass in columns and values, right? So columns are, just like let's say you're creating a data frame, what are the columns you need, right? So just here, in our case, we're taking the entire row of user IDs and we're converting it into columns, right?
okay, sorry.
And what do we want to fill in the values with, right? So when you create a data frame, you create a column and then you fill in with a particular value or any values, right? So in this case, we pass in an argument to values. So here we're filling up the entire data set with the ratings. Okay. And then, we usually have index in data frames. So it starts from 0, 1, 2, 3, 5, and so on, right? So in this case, what do we want to set our index as? In this case, we want to set our item ID as an index. That's about it. Does that make sense? The values inside are the number of ratings. That's correct, right? So if you look at the arguments to pivot to the function, you have the columns, which are user IDs, the values, which are basically the data that you're filling in, which is the rating. Please close that left side files for the screen. Oh, you can close the panel on the side.
Yeah, sorry.
Or you can zoom in a bit so people can see. There you go. Okay, hopefully that makes sense. Is everyone clear on that?
Okay. Is so someone was saying this is number of this is not number of, this is the exact rating which user has given.
What are the numbers?
This is the exact rating. So user ID 1 has given use item ID 1 as 5. Yes.
That's correct.
Okay. Now we are calculating this sparse matrix, which is basically so sparse matrix. What it will do is it will remove these zeros. This will help to increase our computation. So let's say if there are some zeros inside it, so and we don't need in our calculation, so it will drop it for this item ID. Got it? So it will not show here, I think. So let me, I think it's an object, but I'm not sure it will be working like this or not. Print I. Okay. See, so this will happen here. So we will create, let's say for all the item.
All the non-zero values will be shown up.
Yes. That
So basically, the earlier matrix, it had a lot of redundant values, so a lot of zeros. So and they were using up like precious space for us. So that is why we converted into a sparse matrix, so that only the non-zero values are stored, and we can still treat it like a matrix.
yeah, clear? So similarly, now what we will do is we have created user item sparse matrix. Now we will calculate the item similarity. So we have seen here how to calculate this item similarity. This is the formula cosine between movie 1 and movie 2. There are multiple ways to calculate it. Like this is cosine. If it is only 1 or 0, we can use Pearson coefficient here, because we are not, it's just a flag whether it is 1 or 0, if user has checked it or not checked it. Fine.
Yeah.
Any question?
So I have a question. So in this whole operation, like let's say we have Netflix, right? So there are like let's say 100,000 movies and 1 billion users. So let's say we do item similarity over there. So like so it is a static thing, right? So it is not updated as long as new. Okay. So as new users add up, so they get new ratings. So the matrix updates, right? So we have to calculate it like regularly.
Yes, there will be cron for it. So every time
Yeah.
it will get updated.
So probably it should be something like monthly or something like that. Whenever
Or daily basis. Yes.
There's also the user's preferences changes, right? I mean, there's no steady, it's not constant, right? The preferences always changes. So if you like something this week, the chances that you might not like it next week or so on. So I think I'm not sure how our pipeline runs at Decathlon. We have a big recommendation system, and I'm not sure if it runs weekly or monthly basis, but it's run very often.
So which is the like most expensive operation over here? Is it the cosine similarity part?
Yes.
Okay.
So basically, I think I was saying that in cosine similarity, we don't consider about the magnitude. So it is considering 1 or 0 basically. So what I was by mistake I said this, like here it is taking 5340, but it is only taking if user has watched it or not watched it. Okay, so here magnitude is not important, but
This
in case
was
of
Pearson, right? This was Pearson, not cosine.
in case of Pearson, magnitude is important. In case of cosine similarity, magnitude is not important. So when we are saying that this 5.12 is the similarity, we will going to see users, whatever user A has watched, user B will watch. We can be recommended. If there
So
is
this formula contains the magnitude as well, right?
yeah, cosine similarity don't contain the consider the magnitude. Pearson consider the magnitude.
So the formula in the slide, so that is Pearson actually.
No, it is cosine
It is
similarity.
cosine.
Yes.
So but it is considering the magnitude, right?
No, it is not considering.
Magnitude of the rating.
So basically, when the magnitude are important, it is considering, let's say here it is we are finding this value, but while recommending we are not considering it.
Okay.
Yeah.
Got it.
Yeah, I think I made as more concern.
So the question, so anything above 0, cosine is considered as 1.
Yeah, anything which user A has watched is considered to be can be suggested to user B. Yes.
So Dishan is asking ratings don't matter. I think they do matter, right? Because let's say we'll be putting some threshold on the cosine similarity, right?
Yes.
So
Basically,
where it will matter.
it will matter, but when this there's a something called when there's a continuous variable, then Pearson is much more preferred compared to cosine similarity. That's what I'm trying to say.
Yeah.
There are two
but
types of calculations. When there's a cosine, there's a Pearson. and there is Jacobian also, but cosine is compared when their ratings are like 0, 1, 2, 3, 4, 5, let's say. And when the ratings are 1.5, 1.6, something like that, or some is a continuous variable, then Pearson is preferred.
So basically continuous versus discrete, right? So when you have discrete values, then the other versus continuous.
So just to answer, like ratings do matter in cosine as well, just not much.
Much, yes, compared to Pearson, if you are talking about.
Yeah, because in this case, if the rating is less, obviously the cosine similarity value will be less.
Will be
So
less.
it may be less than the threshold, and then the recommendation, there are no recommendations to other user.
Yes. So yeah,
Okay.
but we are finding it like whether the user A has liked it or it not by the rating only. Like if he has given it 5, it is like more likely he liked it, and if he has given 1, it is like he didn't like it. Okay.
I have a question.
Yeah.
Sorry, based on what Aishit was talked about. So it is said that the cosine similarity computation is difficult, as in because of the fact that there are large number of users and because the recommendation systems are too huge. In our case, considering Flipkart or Amazon or Netflix. So my next question is like, when you work in the organization as a real data scientist, is it that all these are runs on GPUs or TPUs? Am I understanding it correct?
Basically it's also run on like it depends. Like if you talk about item to item similarity, the number of items will be fixed, so it will not be like very high, very large. Okay. But when we talk about user similarities, the number of users can be like 30 million, 40 million or something like that. Okay. So in that case, we use like some architecture like Hadoop or Spark something. Mostly because this is structured data, so we don't prefer going to GPU compared to we will try some some framework like Hadoop and Spark.
So basically, if any framework that allows you to parallelize operations, so that is used.
Yes. Is that clear?
Yeah, let's move ahead.
Okay, cool. After that, yes. So after that, we calculated this cosine similarity, which I have talked about it previously. And after that, we move to get similar users. Okay. So no, we are talking about this here. So we were here, no? Yeah. So now this is another 3 points, which is for our cold start problem. This is item metadata, where we are dropping this column item ID, movie title, release date, and all these things, and then converting this CSI into values. We are only taking these genre columns. So if we drop this, let me show you how it looks like. Okay. So now this is mostly genres of the movies. Okay. I'm audible.
Yeah, all good.
Yeah.
Yeah, it's good. All good. All good. You can
Yeah,
carry
yeah.
on.
Yeah, cool. So this shows all these genres. So we will calculate the same sparse metric here, and again the cosine similarities between them. So between all these actions and all. Okay, then we will save it in item metadata similarity. So let's say, yeah. So after this all calculation, we will go to get similar items. So if we talk about get similar items function, So here we are checking the user item. We have created the user item matrix, and taking if the sum is greater than 0, and so we will find the number of ratings. Okay.
Sorry to interrupt.
Hmm.
I have one question. So we are calculating the sparse matrix after doing the pivot thing,
Yes.
right?
Yeah.
So that is to get rid of all the zeros things
Yes.
to make our computation as minimum as possible.
Yeah.
So if I understand it correctly, this first matrix which you've created is a index or rows of movies, that is item IDs, and the columns are user IDs, which is nothing but users, like
Yes.
943 users in the
Hmm.
head which we are seeing, and 5 movies, correct?
Yes.
So, and then what second step was calculating the sparse matrix, so to get rid of all the zeros. So uh, okay, I think okay, but yeah, okay. Anyways, I'll ask the question. You can correct me if I'm wrong, if I'm understanding. So in the first example, basic example, we calculate the cosine similarity, and in that example, whenever a movie, whenever a matrix index. So, whenever a matrix index that is rows and columns value is 0, which means that the user hasn't watched that corresponding movie, and based on the cosine similarity, we are trying to recommend that to other. Is it like we are violating the the very idea of what we discussed about in the previous example, because we are getting rid of all the zeros here, right?
No, we are not getting rid of zeros now, but we are just calculating the cosine similarity. So
I'll explain. So you're not getting rid of the zeros. You are just saving the space.
Okay, yeah.
Because
Yes.
this whole algorithm already know number of items and number of user IDs.
Yeah, sorry, while asking the question, I got I myself got the clarification.
No,
Thank you.
So what we are doing here is user item matrix. If it is greater than 0, and we will check the sum. If the number of ratings, and for this the item ID which is a parameterized, we are putting it here, and is greater than the minimum rating, we will find that items we will get the similarity score by item rating. If it is not, we will do it from item metadata.
So basically, if a movie does not have at least 5 ratings, then you don't do item similarity on that. You do a cold start on that.
Yes, basically. So this is for because we calculated this item metadata on the genre basis only. So this is calculated by our similarity matrix, but this is calculated only on genre. Okay. So after that, what we'll find that we'll find out the what are the similar IDs which are mapped to it. Okay. And here what we are doing it, let's say we have given this item ID, and if you talk about the similarity between item ID A and item ID, like similarity between itself, let's say movie 1 with movie 1, it will be always 1. So we are removing it here. Is it clear?
Yeah.
Okay.
Yes.
So now we are returning the similar item IDs and their similarity scores. Okay. So this we are using all this here to get the similar item IDs, and after that we are finding the movie titles based on these item IDs. Is it clear?
All right. So I think we can go to the GitHub now. Right.
So let's say this we have deployed this part. So for example, we have done it for item ID only. Let's say some movie.
So you can share this URL in the chat.
Okay.
So everyone, you can also open this URL and you will see this deployed app. So what is being done here is you get a search box. You can also select any movie from drop down, and it will show you the top 10 movies very similar to that movie. depending on whether, so if the movie that you selected has enough ratings, that is at least 5 ratings, it will do an item similarity on that and give you the top 10 movies. And if not,
basically it will give top 9 rate movies because one we are removing the one by itself.
correct. So top 9 movies, and if there aren't enough ratings, then we'll do a cold start and still top 9, right?
Yes.
Yeah.
Does anyone have any questions? So if you were to summarize it, right? So how many steps it took, to do the entire recommendation system, right? So from my understanding, because again, I never worked on recommendation stuff before, I feel like it's only 3 steps, right? So one, you have users table, you have items table. You compute cosine similarities for the users and for the items, right? So that's the second step. Third step, just get similar users, right? So where we put on a threshold, which is the minimum ratings. So if we have ratings that's above the minimum ratings, then we do user similarity. If not, then we do the cold start. And the rest of them is just matter of extracting how many do we want to recommend, right? Do we want to recommend top 5, top 10, and so on and so forth. So the rest of them I just consider that's post processing, just to extract the final results and show it to the users. Right? So just have any questions? Did it all make sense? Was it easy to follow? Was it worth it attending the session? Did you guys learn anything?
Yes, it was useful, and thank you, three of you. Like, is this will the use cases be more different? At least my specific, or to be specific, like at least from the interview's point of view, when we are applying for any data science interview, is this kind of understanding will be enough, or do we have to can you suggest us some more use cases where we have to apply some other different techniques, or to get us used to such kind of these things?
So for the basic, like for the fresher interviews, this kind of knowledge will be sufficient enough. Basically, if you talk about item similarities and user item similarities. So one more thing I want to show you, like here we have calculated all these same things for the user item metrics. Okay. So if you see, if you just I'm comparing, I will answer you. Just give me a second. So if you see here, user item metrics, we have calculated here. It is item or it is user ID. Okay, and the values are rating. For the user similarity, we are calculating it on index is on user ID and columns are item ID and values are rating. Okay, so all these things are same, kind of similar. Just we are changing this pivot value, and what we are getting in the result is are the similar users. But we are not going to show someone these similar users. So what we are going to do is finding the items which these users are have seen, but this the user one which have not seen. Okay, got it. So like if you understand the basic of item similarity, user item similarity, and with some business knowledge, that will be sufficient for any interview, or like for freshers.
Yeah, and thank you. And can you suggest us some more examples, or if possible, if okay, could you share us some links with of examples of such recommendation systems, so that will be helpful for people in the group?
Okay, I think there is a
the blogs, right? So different companies have their blogs, right? So Swiggy has Swiggy Vibes, I think Netflix, Airbnb, Zomato, all have their own blogs and they describe their recommendation systems over there. So definitely check that out. And I think Sushant will give us some links and we'll send it over to you via mail.
Okay, so one thing like this Swiggy and all will be little tough if you are just starting in this data science field. So I will suggest there's a Insta cart competition which was on Kaggle. You can check that. I will also share the link of it, but it was quite useful and it is more towards retail business, but it is quite useful if you get the data of real retail business. And you can try multiple things, and Kaggle have a lot of like discussion in their discussion section. There are a lot of things you can learn from there.
So if I remember, I think Netflix hosted a competition on Kaggle, right? So that was also for recommendation only, right?
I don't remember the Netflix
I think it
one.
was like some
When
million
Netflix
dollars.
Yes.
are you talking about the $1 million prize?
Yeah, $1
Yeah.
million
Where the
prize.
entire
16,
that's
17.
where all the
2016,
yeah,
17.
that's where all the recommendation stuff came to
So
existence.
adding to the point, so there is a one vector engine is there. Sushant, you can search right now vector engine by the NEC Corporation. So this is the hardware where the all the telecoms users used to buy it because the recommendation is in uses sparse matrix. It is of highly intensive process, and I have done the benchmarking of the means solutioning of the Netflix data and all these things. It done the processing within 30 to 40 minutes compared to the other GCP and other systems.
Okay.
Yeah,
Uh,
because you worked in recommendation for the hardcore side, so I just thought to tell you
yeah.
there is a hardcore hardware is itself available for the recommendation engine, and for Redis is the open source library
Okay, I will
by
check it.
NEC Corporation, Japan.
Okay, amazing. Cool. So I think this is so let me why I'm not able to open my chat.
So if you're done with the session, so I just want to remind everyone, what was the goal of the session, right? The goal of the session was to create a data science portfolio and do a series of projects that you can put it on your portfolio. So this is the third session that we have done. The first one was done by Ashit. It was on the computer vision side, so object detection. And the second one was done by me, which was on sort of e-commerce, so marketing, customer lifetime value, and so on. This is the third one, and we're going to be doing a final session where we'll put everything together in a portfolio, and then that's about it. So for people who have joined for the first time, you might not be aware of what portfolio I'm talking about. So I'm just going to quickly share it with you guys before you leave. And if you're interested in creating your own portfolio, I would say join us next time. So let me see. Can you guys see my screen?
Yeah.
Okay. So this is a portfolio that we started out from the very first session. So this is something that we're creating. Okay. So in the very first session, we did a bunch of things, right? We took this portfolio, we updated it, we changed a bunch of stuff on here. And then we changed the content here. We're just going to update some pictures, and I'm going to show you how you guys can put your GitHub profile here. You can put in your about, so you can share your experience. So here, I just took an example of data in production, and you can see the timeline for it. You can put your team, and the pictures and stuff will change it next time. So we're going to complete that type portfolio. Okay? So we'll condense all the projects together and we'll put it on GitHub so you guys can find everything in one place. And yeah, so I would encourage you guys to create portfolio, share with us. We'll be happy to share it on LinkedIn with the networks that we have. Any questions?
Yeah, so before anyone leaves, I've shared a QR code in the chat for the refund form. So feel free to scan it and fill out the form.
Yeah, don't forget to scan it because again, this is a one-time thing. So you better scan it now because you won't be able to share it afterwards. So if you want a refund, just scan it and go to the refund. So the topic for the next session will mostly be about portfolio. So how to finish up. So all of these projects that we have done, will complete the entire portfolio. So there won't be any sort of data science project session. It will be mostly how you finish or wrap up with the portfolio and be done with it.
So we will keep doing these master classes, but for the next session, we'll just compile all these projects together and put it in a portfolio so that you know how to actually showcase whatever projects you do,
Yeah.
so that you can get a better job maybe.
So yeah, so we'll finish up these series of sessions and then we'll start again with some interesting data science projects. We have a bunch of people working on many interesting topics. We'll invite them and we'll do hands-on. And
All
if
right.
you guys are interested in any topics, send us a message and we'll try and see if we can do those.
Yeah, so anyone has any recommendations for any topics, so yeah, feel free to put it in the chat, or email it to us, or tell it to us over LinkedIn. Just tell it to us anyhow.
The final thing that I wanted to share was our website. So feel free to go check out our website. We offer data science training if you guys are interested. Feel free to check that out. In addition to that, so I've been working on putting together the documentation, a bunch of things that beginners should know, and I use this to train our students. So feel free to check this out. I'll put the link in the chat. You can also find everything on here. So you will find podcasts that we have done in the past. You can find the YouTube link. In addition to that, you can find the documentation here. Okay. And you can find more info about the mentoring program. And that's about it on my end.
Yeah. All right. So thanks everyone for attending, and see you in the next session soon, probably next week. So yeah, let's end it.
Thanks, Shushan.
Thank you guys for bearing till the end.
All right. Yeah. Bye everyone.
Okay, see you.
Thank you.